All right, so you might be thinking, what in the world have we been doing? Well, we've been talking about these different data displays. So I had you guys go through and kind of think about which ones do you know how to do and which ones don't. So a lot of you guys were unfamiliar or didn't remember about your box and whisker plots. So that's where your homework yesterday was to refresh yourselves. This is really showing the variability of your data by using different quartiles. What are the 5 things that you need to go into a box and whisker plot? Because this whole section is talking about what are our best displays of data given, or I'm sorry, what are our best graphs to use given different displays of data? And you'll kind of see what that means in a second. So these are all important to know, so I'm going to keep them to the side here for your notes. So here's your notes for today. So if I were to look at here, so choosing data displays, use your list. This is your list. Use your list of given data graph displays. So for example, the number of students in a marching band per year. Well, I want to think about which one of these would be the best way to display the number of students in a marching band each year. Now, think of the different things that go into this right now. I have students and I have year. Now, year is something that you would associate with time. So if I look over here, I want to see which one of these would best be described being associated with time. And so I can see that if you look at your own list, the line graph actually would be the best. And this is because a line graph, this shows changes over time. So that's kind of your reasoning. You could say, oh, it would be the line graph. Well, why? Because right here, if I look at a line graph, this shows how data changes over time. And I want to show how the number of students in a marching band changes every year. Let's go to number 2. What if I wanted to show a comparison of people's shoe sizes and their heights? Now look and read at all of these. If you want, you can pause and see which one you would choose and then see sort of what I would choose. There really is no right or wrong answer as long as you can back up your choice. So a comparison of people's shoe sizes and their heights. Think of the different variables you're using here. You have shoe sizes, but you also have heights. So the one I'm going to say to use for number 2 is, and see if this is what you chose, a scatter plot. A scatter plot. And you might be thinking, okay, well, how do you back this up? Why do you choose a scatter plot? Well, this is because I want to compare 2 different sets of data. I'm comparing my shoe size and I'm comparing the heights. So a scatter plot would be an extremely appropriate display of this example for number 2. A scatter plot shows the relationship between 2 data sets by using ordered pairs in a coordinate plane. So you could show that shoe size, kind of like a bar graph, but a little bit different. But you could show that trend going up. Remember when we talked about correlation? So does your shoe size grow when your height grows? This would help explain that. What about this third one? The population of the United States divided into age groups. So think about right now, dividing into age groups, that's talking about categories. So I know I'm going to be talking about categories, but it's really what? Age groups? If I say from 10 to 15, that's known as a frequency. So if I wanted to have all of these different age groups, 10 to 15, 15 to 20, 20 to 25, those are frequencies, so I'm going to want to use a histogram. A histogram is what shows frequencies of data values in intervals of the same size. So for number 3, you could say something like a histogram. I don't know. Oh boy, what is going on? So a histogram, because you could say something along the lines of frequency of ages you have and the intervals of the same size. So you could say you have frequencies of ages, plus you have intervals that are the same size. The population of the United States, these intervals would be the same size, meaning You could do, your intervals would be in ages of 5. So 5 to 10, 10 to 15, 15 to 20, 20 to 25. You don't want to make a histogram and say, oh, ages 3 to 9 and 9 to 100. That's going to be very skewed. And then this last one, so the percent of students in your school who play basketball, football, soccer, or lacrosse. What data set, choosing from these, am I going to want to use to show the, and this is a keyword, percents of the different students in your school who play these sports? So I actually think the book says one thing. I think there's two. I think a bar graph or a circle graph would be really good for dealing with percents. A bar graph shows here, I could say this, my percentage is up on this side. A circle graph, you often see it breaks things down into percentages. So either a bar graph or circle graph would be great for those. All right, let's move on. And I want to kind of just walk through with you one more example. Okay, so let's see. Sorry, I'm not great at these. Okay, so, you know, I want to walk through you guys another example of something that you'll be sort of asked to think about and do. So this example is talking about identifying an appropriate display of data, because often a lot of different data displays will try to skew your mind and thinking. So you record the number of hits for your school's new website for 5 months. So for example, your school has a website. Here in August, there were 250 hits. In September, 320, October, 485, November, 650, December, 925. So you can actually see here how this is growing. So each month, your hits are growing. So I want you just to look at this data set on your own. Think about right now, what are some things, without even looking at any of this else, any else of this, just by looking at your hard cold facts. What is happening? In August, there's 250 hits. In September, there's 320 hits. In October, there's 485. What is happening? Every single month, August, September, October, November, December, my months go in order. Every month, my hits are growing. They're growing. And how much are they growing by? Are they growing by a consistent amount? From here, they're growing about 100. From here, they're growing a little more than 100. From here to here. Okay, just kind of observe. Because now, tell whether the data display is appropriate for representing how the number of hits changed during the 5 months, and explain your reasoning. So we've already identified your hits is growing. Now if I look at A, I want to think, is this an appropriate graph to show the trend of what's happening? August, September, October, November, December. Just visually, I see that this is going up. It's a pretty steady incline and it's going up. My number of hits is going up each month. So the bar graph shows the number of hits for each month. So yes, this is an appropriate display of data because I'm talking about my months and my hits. What about B? The histogram here is showing the number of hits from, it looks like, okay, so how many, and see, this is already getting kind of confusing. This histogram, it does not show the number of hits for each month or how the number of hits change over time. It's not an appropriate data display. This looks like it's trying to show you the frequency of the number of hits. So how many times do you get hits from 0 to 399? How many times do you see over here a number of hits from 400 to 799? That's irrelevant. We don't like that one. That one does not show what we're trying to display. And lastly, a line graph. So this one basically just has, it's very similar to our bar graph. It's just using a line graph instead. So it has, again, my months and it has my number of hits. So this is totally showing the incline of hits using both my variables. So yes, this is also a correct data display. So if you were to be given something like this, and if I were on a test to say, oh, which data display would you use? Some of you might choose something like A, some of you might choose something like C. Either one of these is correct, but don't choose something like B. You know, so there are multiple correct answers, but there are also multiple incorrect answers. So the last ones, if you want to go Tell whether the data display is appropriate for representing the data in example 2. So what about a dot plot? Would I want to use a dot plot on this example right here? Go back to your list of all your data displays. A dot plot shows the number of times each value occurs in a data set. So think about if that would make sense or not. Would that make sense? And the answer for that would be no, a dot plot would not make sense. Well, what about here, a stem and leaf plot? Well, would I want to show a stem and leaf plot? No, a stem and leaf plot would not show how the number of hits changed over time. So there's a